The active material in the grids include the sulfate, that is the tribasic and tetrabasic lead sulfate, pre-lead, and moisture. Once the target values for these materials are determined that are to be achieved after the curing, it is essential to understand how to achieve them. And this can be accomplished by determining the appropriate set points for the curing process. And this curing process includes the loading cycle, humidification cycle, drying cycle, and unloading cycle. Hello everyone, this is Saili Abhijit Sawant, and in today's video I will be talking about the necessary steps to achieve the design target ratios. Specifically, I will go over the details of the set points that need to be determined. The set points that need to be designed include temperature, humidity, air velocity over the active material, and the control of exhaust air inlet and outlet dampers. A skilled process designer studies these parameters and determines the appropriate values required to achieve the design ratios. The effect of temperature has been explained in the last video, and accordingly the temperature set points are determined. The next is humidity. Moisture in the air acts as a catalyst in the lead to lead oxide conversion, that is the oxidation of the active materials. Coming to the next point, air velocity over the active material. Air movement is one of the most crucial parameters in the curing process, which is often overlooked. So what is the role of air movement? The temperature and humidity set by the operator must effectively reach the active material, and this is achieved through proper air movement. During the humidification cycle of the curing chamber, the presence of oxygen and moisture in the air near the active material triggers a necessary chemical reaction. This air needs to be replaced gently and continuously to ensure a consistent supply of oxygen and moisture to the active material. Therefore, during humidification cycle of the curing chamber, a gentle or a slow speed of airflow is required. Conversely, during the drying cycle, the moisture generated needs to be removed as quickly as possible. Therefore, during this phase of the curing chamber, a high velocity airflow is necessary to efficiently dry the active material. Which leads us to the next point, control over the inlet and outlet dampers. During the humidification cycle, both the dampers should be partially open to inject oxygen into the chamber, which is consumed by the oxidation process. Control over these dampers is critical because excess exhaust can lead to the loss of humidity and hot air inside the curing chamber. This results in increase in consumption of air, water, and steam, which leads to the increase in the operational and the running cost of the curing process and the curing chamber. And hereby, I would like to proudly highlight that Abhison's curing chamber are equipped with features designed with previously mentioned technical parameters in mind. This features reduces the operational cost of curing process, increases efficiency, which in turn helps our customers increase the carbon credit and reach the sustainability goals. Now let's take a closer look at this graph which illustrates the key parameters involved in the curing process over time. On the horizontal axis, you can see the cycle time divided into different phases, that is the loading, humidification, transit, drying, and unloading. In each phases, different set points can be added. For example, in humidification, you can see humidification 1, 2, 3. Similarly, in drying, the left vertical axis represents the temperature while the right vertical axis represents the humidity. The red line indicates the temperature and blue line indicates the humidity throughout the curing process. During the loading phase, temperature and humidity are at baseline levels. Airflow and exhaust are relatively low to maintain the initial conditions. As we move on to humidification, there is a rise in the temperature and humidity. Airflow and exhaust are adjusted to ensure adequate oxygen supply without excessive loss of humidity. In the transit phase, the parameters stabilize briefly before preparing for the drying process. In the drying phase, the humidity drops significantly while the temperature remains relatively higher. A higher airflow is maintained to effectively remove moisture from the active material. In the unloading cycle, the temperature and moisture return to the baseline level as the curing process completes. In conclusion, once the target values for the active material are set, achieving these values requires a precise combination of temperature, humidity, airflow, and exhaust. By carefully controlling and adjusting these parameters throughout the curing cycle, we can optimize the process. It is essential to validate and fine-tune the settings to ensure they meet the desired outcomes. This iterative process of adjustment and validation is the key to achieve optimal curing condition and consequently the desired material properties. So this is it for this video. Thank you so much for your time and attention. If you have any queries regarding curing chambers or any of our products, feel free to contact us anytime. Thank you once again and stay tuned for our upcoming videos.